So, dear colleagues, ladies and gentlemen, it's my great pleasure to welcome you all to today's seminar on bioeconomy as an approach towards sustainable development. My name is Regina Bierner. I'm the chair of social and institutional change of agricultural development at the University of Hohenheim in Germany, and also a member of the German Bioeconomy Council. This seminar is jointly organized by the Biomonitor project, the Sustainable Co-Production project, two projects funded by the European Union, and ICABR, the International Consortium on Applied Bioeconomy Research. We are very happy that we have the opportunity to interact with you today in this seminar. We have 4 distinguished speakers and a 5th distinguished colleague who will give the closing remarks. And I will introduce our speakers at the point prior to their presentation. Let me just say a few words, one for the organization. So we will first have, after my introductory remarks, have the 4 presentations back to back. In the meantime, you can already use the chat functions to write your questions into the chat. After the presentations, we will then pick up your questions, hopefully all of them, and our speakers will answer them, and then we have the closing remarks. So the topic of today's seminar, I think now my camera may be frozen. So the topic of today's seminar is bioeconomy as an approach to sustainable development. Without taking too much time, a few introductory remarks on our topic. Bioeconomy has gained increasing recognition worldwide. We have an increasing number of countries that have bioeconomy strategies and policies. And the European Union certainly was an early leader in this process. But now we are a global community that deals with the bioeconomy. For example, we had 3 global bioeconomy summits already, and also ICABR, the International Consortium on Applied Bioeconomy Research, is promoting the topic at the global level. Bioeconomy is mostly understood as having 3 pillars. A bioresource pillar, replacing fossil resources by bio-based resources. A biotechnology pillar, using modern biotechnology in all sectors of the economy, all sectors of industry. And the successful development of mRNA vaccines to deal with the current pandemic is certainly one of the highlights of this pillar of the bioeconomy. And then the 3rd pillar is making sure that the bioeconomy is indeed sustainable. As the concept of the bioeconomy has become more recognized all over the world, there has of course also been criticism of this concept. And there have been concerns often formulated by civil society organizations whether bioeconomy solutions are indeed sustainable. There are, for example, concerns for a competition for land between food production and biomass for the bioeconomy. There are concerns about the social implications and others. And therefore, it's very important to make sure that bioeconomy solutions are indeed sustainable. And this is where concepts such as the circular economy as one essential feature of the bioeconomy also become important. So the common understanding is that bioeconomy should be part of a larger process of the transformation of the economy towards sustainability. And today we have 4 very interesting presentations that will look at this question on how to have the bioeconomy as part of this transformation from different perspectives, also with different examples. So without further ado, I think I cut my remarks a bit short, so we have really time for our presenters. I would like to introduce the first presenter to you, and that is Professor Eustos Vessler. He will talk about bioeconomy, sustainable development, and well-being. Eustos Vessler is the chair of Agricultural Economics and Rural Policy at Wageningen University and Research in the Department of Economics. He is also the president-elect of the ICABR, of the International Consortium on Applied Bioeconomy Research, and certainly one of the most known scholars on the economics of biotechnology He also has looked in his research on value chains and regulatory economics, and he also focuses on the contribution of value chains to sustainability and the impact of new technologies. And he has widely published in this field, and so we are very interested, Eustos, and look forward to your presentation. And to the audience here with us, please use the opportunity already while our presenters are speaking to put your questions into the chat. So Eustos, the floor, or rather the screen, is yours now.
Yes, can you hear me?
Yes, we can.
Great. Yes, thanks a lot. Angelique, can you share my screen? Okay. So this may take a few seconds before this is loading. And you should now be able to see my screen. Is this correct?
Yes, it's correct. We see your screen, and we see, right now, we see, I think, the last slide of your presentation. So we may have to.
Oh, that's interesting. Now you should see
the first. So I think
now you see the first one.
Good to go
fantastic.
now. Yes.
That is great. So Regina, many thanks for the nice introduction to the topics that we love to address today. Now, our topic is on sustainability and the contribution of the bioeconomy. And what I will address is the issue of bioeconomy, sustainability, and well-being. Now, Regina Bierner has already mentioned the EU as being one of the front runners with respect to a bioeconomy. And here is the statement from the 2018 updated bioeconomy strategy of the European Union. And they explicitly stress here that a bioeconomy development should contribute to the prosperity of its citizens, which we can basically interpret as contribution to well-being. But this is not only an issue that is relevant in the European Union, also many other countries around the world have put their bioeconomy on their policy agenda. Now I have to become a little bit more technical for the introduction to stress a link between well-being and the bioeconomy. And basically, when we talk about well-being from an economic perspective, then we think about improving the benefits over time. And economists have defined sustainability as a situation where we have non-declining intergenerational well-being. Now, when we link this with the development of the bioeconomy, what we have to take into consideration, and that is where I now refer here to the figure on the left-hand side, where we have on the horizontal axis our values, and where we have on the vertical axis on the bottom the irreversible costs, and on the top part the net present value of investments into the, for example, the bioeconomy. Now, when we take into consideration that many of the investments in the bioeconomy basically are connected with uncertainties, meaning to say it's difficult to tell from today's point of view how exactly specific investments in the bioeconomy will develop over time, as it is difficult to forecast how price developments will be, how climate change will affect our well-being, and so hence and so forth, that uncertainty basically increases the benefits needed for justifying an immediate investment into bioeconomy activities. And you can see here with I1 and I2 indicated what we mean with what illustrates irreversible costs. And what you can also see that if irreversible costs increase, for example, if we talk about investments cost, or if we talk about implications for the environment, so a downward movement, that the benefits indicated on the horizontal axis with V have to be larger to justify the compensation for the increase in irreversible costs. Now, this kind of concept has been widely introduced in the literature. There was a report by the Commission for the French government with Fitoussi, Zen, and Stiglitz on social innovation. There was this year recently published the report by Partha Dasgupta on natural capital, and basically all these studies refer back to the Principle 15 from the Rio Declaration, where it stated that in order to protect the environment, the precautionary approach shall be widely applied by states according to their capabilities. Where there are threats of serious or irreversible damage, lack of full scientific certainty shall not be used as a reason for postponing cost-effective measures to prevent environmental degradation. Basically, what this says, we need to take irreversible cost explicitly into consideration, and that is basically what this framework that I have introduced does, because it tells us that for 1 unit of irreversible costs we need more than 1 unit of benefits to compensate and justify immediate investment. Now, to translate this into practice, what at policy or project level is often done is to use the framework that has been introduced by the OECD, which refers to the drivers, pressures, state, impact, response framework, which I have summarized here, where we have on the left-hand side the drivers, then in the middle we have the state that is influenced by policy strategies, but also has impacts on our resources, and that is also influenced by, for example, objectives as identified here on the right-hand side with the societal challenges. And as already has been pointed out by Regina Bierner earlier, the bioeconomy, of course, is embedded in the wider policy debates and discussions that are linked to also the circular economy and the green economy, and this we have to take into consideration when we talk about the contributions of the bioeconomy towards sustainable development. Now, if we look at the European Union, in their strategy paper, they have identified 5 major societal challenges that should be achieved by investing into the bioeconomy, that include food and nutrition security, sustainable natural resource management, dependence on non-renewable resources, mitigating and adapting to climate change, and employment and economic competitiveness issues. Now, that is where there are expectations with respect to the contribution of the bioeconomy. The challenge then is how can we measure these contributions, and for this a number of indicators have been developed by different projects. And for example, within our Biomonitor project, where I'm the coordinator, we have also looked into some of the indicators that can provide a contribution to measure the societal challenges. And what we in particular have done is concentrating on some of specific sectors of the bioeconomy that so far have not received a lot of attention within the debates, and derived indicators related to those specific sectors. If you like to see more, we have the Knowledge Center for Bioeconomy run by the European Commission. They provide information about the state of the art with respect to measuring and monitoring the bioeconomy, and we as a Biomonitor project contribute to this. And here I would love to show you one of the results that we have prepared within this project, and that is related to the value added contribution of the bioeconomy. And we have summarized this here in a dashboard. I just put a snapshot from this dashboard, and there you can look at different sectors of the bioeconomy and identify what is their contribution. You can play around with this. You can look for your own country. You can look for your own sector that you have an interest in, and calculate and identify upstream, downstream, and major bioeconomy sector shares. Now, what is one of the interesting and novel contribution of this dashboard that we have created is linking the bioeconomy, what we would consider 100% bioeconomy, with up and downstream sectors. So the upstream sectors provide an input to the bioeconomy, and the downstream sectors use outputs from the bioeconomy sector. And if it takes this together, and this year is highlighted for the year 2015 for the EU member states, what we see is that in many cases, the up and downstream sector are as important as the main bioeconomy sectors. And that is important for getting a complete picture about the contribution of the bioeconomy to our well-being. And with this information, we can derive further indicators, as I mentioned before, that are linked to societal challenges. Now, this was my introduction to this issue. Now we will continue with 3 more presentations where we get more detailed information about how the bioeconomy is contributing to well-being by, on one hand, looking at contribution to decarbonization and biodiversity, and then having 2 interesting case studies, one that looks into the situation of producing hemp, and the other one extracting biopolymers from a transgenic tobacco and use this for sustainable products derived from the bioeconomy. And what I last but by no means least want to mention is that this is a kickoff event. We have 2 further events on June 10 and 11 where we inform in more detail about the Biomonitor project and our engagement with stakeholders. So please stay alert and look for future announcements and invitations for these other 2 events. With this, I like to finish my presentation and head over back to Regina Biernhoff for introducing the next speaker. And thanks a lot for your attention.
Well, thank you so much, Eustos, for leading us into this afternoon's seminar. I think that was really a great overview of the relevant topics, and also going back to the theoretical economic foundations of it. So I would like to invite the audience, please ask questions in the chat so that we can pick it up. Yeah, you're really welcome to ask questions while the speakers are speaking. We will not forget those questions. They will be picked up afterwards. All right, and now it's my great pleasure to introduce our next speaker of this afternoon, and this is Professor David Silverman, who joins us here from the University of California in Berkeley. David has been a professor in the Agriculture and Resource Economics Department there since 1979, and he holds the distinguished Robinson Chair there. And David is certainly one of the most widely published and widely known members of our profession. His work has a strong focus on issues related to technologies, biotechnology, and the bioeconomy in particular. David is a fellow of the Association of Environmental and Resource Economists and the American Agricultural Economics Association, of which he has also been the president. He has a number of awards, but for reasons of time, I will not list them all, but very distinguished awards. And he writes not only in professional journals, but also for the general public, and aims to integrate economic theory to real-world problems, and has been working both in developed and developing countries. So even though you see on the screen here Eustos Vessler again, so we apologize for this misnaming. So David is waving here, and I hope you all will see him speaking. David, it's really a great pleasure and a privilege that you're taking the time this afternoon to be here with us in the seminar, and this screen is yours. David, we cannot hear you yet. Maybe we try again. It worked before. I'm sure it will work now also. But right now we cannot hear you yet. Maybe you have to find a way to switch on the microphone.
Oh, okay, perfect. Can you hear me now?
Now we can hear you. Great, David. Please go ahead.
Okay, wonderful. Okay, so it's a real pleasure to be here, and I'm speaking for you from Oklahoma. So next slide, please. Okay, so the bioeconomy is really harnessing the power of biological knowledge, technology, and organism to address major societal challenge. My perspective is this: the 20th century was a century of physics, and the 21st century of the century of biology, and the bioeconomy is really helping us in the transition. I think the bioeconomy will bring to the world what the notion will implement sustainable development, and sustainable development requires several elements: recycling, increased input use efficiency, but the most important thing is relying on biological processes that by nature are circular. Now, the objectives of the society and that the bioeconomy will help with is decarbonization and reducing or eliminating greenhouse gas emission and preserving valuable environment and cultural amenities. Next. Now, the bioeconomy can reduce agricultural greenhouse gas emission, and I really view agriculture not only as food, but agriculture is food, bioenergy, green chemistry. Agriculture can result in many outcomes, and I think a key element from it is increased yield, and the bioeconomy can help by using new technologies in terms of plant breeding, in terms of harvesting, in terms of soil management, to move to a system where we rely more and more on renewable resources. Next. Now, I think that a key issue that we have to address when it comes to the bioeconomy is the using of biotechnology. And I think that's the biggest barrier that we have today to implementing the bioeconomy, because when we rely on the bioeconomy, we have to rely on modern tools of biology. And there is a study that was done by Matthew Kem looking at a huge body of literature on the impact of agricultural biotechnology on yield and cost, and you can really see that it tends to increase yield and reduce pesticide use and help farmers. So to me, without using modern biotechnology, and it doesn't matter if you call it CRISPR or GMO, but you really use the new tools that we have based on understanding of the DNA, I think the bioeconomy wouldn't go nowhere. Next. Now, what we have really studied is that already, despite of the heavy regulations that we have, already some of the modern tools of the biotechnology increase agricultural yield, agricultural supply by about 10% in corn and 20% in soybean, and result in reduction of prices. So people will ask, why do we care about reduction on the prices of corn or soybean? And the answer is very simple, because chicken and beef and a lot of the food that the poor needed are relying on this product. The thing that is unfortunate that we haven't been able to use a lot of these technologies to other agricultural products, because once we would do it, then we can really reduce the footprint of agriculture. Next. Now, the other thing that we see is that with the use of modern biotechnology, even though it has been very limited, we were able to move to double cropping and reduce input use in agricultural production. So greenhouse gas emission of agriculture has been reduced compared to what it has been by about 15%, and that's only the beginning. Next. Now, the biggest problem that we have is that regulation really slowed the evolution of biotechnology, and I think the development of the biotechnology. And what we can see is that since 2000, the biotechnology have really slowed, and the main countries that suffered it are developing countries in Asia and Africa. Next. So to some extent, the question that I asked myself, what would have happened, or what will happen if we would really allow widespread use of modern biotechnologies throughout the world? And I think that the recent example of the solution to COVID shows the potential of these techniques. Without modern biotechnology, we wouldn't have the modern vaccine. Now, the one thing that you see is that that using modern biotechnology doesn't affect poor farmers. Most of the adopters of a lot of the technologies are small farmers in countries like India, Brazil. This is a case of BT Code and China. Next. So thus far, we know that most of the modern development that we have using modern biotechnology haven't been used. But what we can really see is that today we have tools that can reduce, that can generate new protein, improve the production of carbohydrate, it introduce micronutrients and improve fiber quality, and most importantly, reduce greenhouse gas emission by animals, because they improve the stability of input. And these are only the beginning. There are hundreds of innovations that haven't been tried that can really allow us to reduce both to reduce the greenhouse emission per acre, but most importantly, reduce acreage. Next. Now, we estimate that the cost of regulation today are really incredible, and it takes about 10 to 15 years to introduce a biotechnology product to the market. It costs about more than $100 to introduce new trade, even though up to now we didn't have any incident of any disruption because of the bioeconomy. So the cost of society was really immense. Next. So I estimated what happened from what was the cost of delaying basically introduction of new varieties that are available under different assumptions, and about interest rate and other factors. And what we can find that the cost in terms of the monetary cost is about $1 trillion from the fact that we don't expand the use of biotechnology, the tools that we have to corn, soybean, wheat, and rice throughout the world. But the cost in terms of greenhouse gases is even bigger. Next. So to some extent, once we were able to use tools of biotechnology, and it's only the beginning, because we have a very, very crude tools, and they are being refined by the introduction of CRISPR, and CRISPR itself is being improved. We can able not only to meet the growing demand for food and to meet the demand for food security, but we will able to reduce agricultural footprint and grow more on existing land. And I think this is now the major point, that when it comes to decarbonization and bioeconomy, the biggest challenge in my view is to reduce how much agriculture, the emission from agriculture, and also allow agriculture to resume to increase the production of inputs that are produced in a way that is non-renewable and generate greenhouse gases. So to some extent, by the same amount of land, if we, let's say, increase the yield of agriculture by about 20 or 30%, which is quite feasible with new varieties that we have and with new crops, you will be able to introduce biofuel. You need to produce fine chemical and you able to produce other products. And in addition, we will be able to sequester carbon. So to me, the main role of what I call farming is to produce food, to produce alternative sources of energy, and to sequester carbon. And all of it can be done with new technologies. Next. Now, so as I said before, the biotechnology is evolving. GMO is only first application, and our challenge is to marry biotechnology with what people call agroecology, to develop systems that we can reduce the way of the use of pesticide and basically try to take advantage of the power of plant. Next. So a key point in all this analysis is that modern breeding can enhance crop biodiversity, because the key point about modern biotechnology is that we operate at the level of the gene. And I think this is, if you ask me what is the essence of the bioeconomy and the biotechnology, and to me are interlinked, that we move from solutions that were like mechanical solutions to solutions that basically are atomistic solutions at the atomistic level of the plant. And the atomistic level of the plant is a gene. So you don't really invent new plants, you don't drastically change variety, you modify them gene by gene, knowing exactly what is the function of each gene. By doing it, you can increase conceptually the number of plants in a much bigger, to become much larger. And the nice thing is that we have data that support this claim. Next. So, for example, if we look at India, where in India we introduced BT cotton, what we can really see is that the acreage of BT cotton increased, and the number of cotton variety in India increased. And today we have many more cotton variety in India than we ever before, because we include both GM varieties and non-GM varieties. So to some extent, we have almost double the number of varieties, and we introduced a lot of varieties that were not before, that we didn't know that we can do before. Now the same thing has happened in corn and soybean in the US. The number of soybean varieties of the US almost increased by about 50%. Next. And again, if we can really look at the data about people about the difference between adopters and non-adopters, next slide, we can really see that even in 2008, adopters had many more varieties than non-adopters. Next. Now, in principle, so what we learned from India is that if you have a strong crop breeding sector and there are no barriers for adoption, the introduction of modern biotechnology increase the number of varieties that farmers have, and together with reduction of acreage that is happening, suddenly you have the opportunity to have higher yield, less greenhouse gases, and more biodiversity. Next. So to some extent, the introduction of a modern biotechnology would allow us to basically to resurrect a lot of varieties and a lot of traditional varieties that basically disappeared. Because a lot of varieties disappeared because of issues of pests, because of issues of changes in climate. But once we know what genes can modify it, it will be no problem to restore it. And already we saw it with respect to livestock and other products. Next. So to some extent, I really think that we really are challenged to have changes in attitude towards biotechnology and bioeconomy. Generally, and I spend all of my life as an environmental economist, and a lot of time we try to protect the environment, and we are conservative by nature, and we try to resist change. But nature is changing, evolution is there. We are dealing with a world that is changing. So today, the key word are not conserve or protect, but the key word is adapt and modified in a way that is socially responsible. And to me, the bioeconomy is about this element of adaptation. And I think the biggest challenge of the bioeconomy is, in addition to decarbonization and maintaining biodiversity, is to providing tools for people all over the world, especially in developing countries, to adapt to climate change. And the key element for adapting to climate change is to have the ability to introduce new varieties and to make existing crop system much better, as well as developing new stream of income that will come by earning from sequestration and reducing greenhouse gases, and that can only be done by modern biology. Now, in the past, historically, it took about 20-25 years to modify an existing production system and existing crops and ecological solution to problem. We need to move to systems that basically are able to adapt within 10 or 15 years. And this is a huge challenge because it includes research, development, commercialization, extension, and adoption. And it only can be done by significant reliance on modern tools of biology that are integrated with the tools of modern data science, as well as modern electronics. So we will be able to move very fast to deal with climate change, as well as other challenges that we have. So to me, we really have to have a change in attitude, to have change in regulation that allow quick adaptation, quick use of new technology in a way that is ecologically and economically careful and sustainable. And I think that to me, that is the biggest challenge and more the opportunities that the bioeconomy is providing us. Thank you. I really appreciate this opportunity.
So thank you so much, David. I think that was a wonderful, wonderful presentation about a topic that I think will also spark quite some discussion here. We already have some interesting questions in the chat. So thank you so much, David. Really appreciate it, and we will look forward to the discussion afterwards. So in reality, we would all clap now, but electronically, I think it's not possible. But thanks a lot. And with that, I would like to move on to the next speaker. And our next speaker is Raphael Doulon. He will talk about the many uses of hemp. And Raphael, together with Daniel Kruse, founded the Hemp Farm, and we will actually learn more about the Hemp Farm. And Raphael is the CEO of this pioneering company. He started with a training in organic farming and marketing and became one of the most well-known experts of industrial hemp cultivation, he says, in Europe, but I would say probably also worldwide. And he has a very long experience in this field because he has been in contract farming of industrial hemp together with farmers and cooperatives already since the late 1990s. So Raphael, we are very happy that you are here with us today and that you speak from your practical experience about this very interesting example. I think it's a fascinating crop for the bioeconomy, and we look forward very much to hear more from you about it. And I would also like to encourage the audience, please ask questions in the chat so we can pick them up later. And with that, Raphael, the screen is yours.
Good afternoon to everybody, and thank you, Regina, for the introduction. As you see, the title of my first slide is exactly that, what we understand of the idea of bioeconomy. So when I'm talking about hemp and bioeconomy, I am showing you now the synergy of ecology and economy with that plant. Why do I say so? That I'm calling hemp a multi-champion of bioeconomy. And for everybody who does not know exactly what is all about this plant, you see here on the picture that we do have a multi-crop here with the hemp plant, and we do have many uses with these products. So we have the flower part, all the green parts, which is a food and which is a medicine. We have the seed part. Hemp is called an oil crop as well. And the seed is very useful for feed and food as well. It has a very high nutrition ingredients. And on the other side, we have the fiber in the straw, and especially the shifts, which are now very well used in the building industry. And you don't see on the picture, but I can tell you that even the roots are very helpful for producing interesting products. It's a matter of fact that I do have pretty much too much slides in that presentation, so I guide you very fast through it to the interesting part when it comes to the bioeconomy. So this is where I come from, the northern part of Germany, in the middle of Europe, where we do have our farmlands. We started in the late 90s, and we increased our acreage now up to 1,000 hectares, which we are now working on with some partners in the agriculture as well. You see my colleague and friend Daniel, who is a co-founder of the company and actually the president of the European Industrial Hemp Association. And you see a part of my team. And here, this is what we are calling our competences. So we are really pretty much vertical, working on many fields about hemp, about the seed, about the plants, and about the products. And we do this not only in Germany and in Europe, but I do have some good and interesting corporations all over the world. This is where I come from. Again, my facilities. And here now it is starting to be interesting what we are calling hemp. I just lost my screen. I'm very sorry. Just a second. It is gone now.
Raphael, we can still see it.
Can you still see me? Can you see it? Okay, good.
We can see your screen and you, but you should also see your screen, of course, as well.
Sometimes so it is very helpful. Absolutely, yes.
So maybe you take a minute and look how you can get it back.
Yes, I'm just trying to find it back. So what you see here, this is a kind of the soil, and the soil with the plants and the roots together, all together. This is exactly what is our system. And I have quite a strange picture here, but it shows the sustainability of hemp farming, and it shows the big impact of what we can do of the sequestration of carbon in the soil and in the products as well. This is very, very important nowadays. Everybody is talking about it, and hemp is doing it. It has a very, very big potential on binding the carbon out of the air into products, and I see a very big future for not only products, but even the impact on CO2 certificates, trading, and so on. I'm showing you now where we are harvesting the top part of the plant. It is a big machine which we are using, and we go several times through our fields with that machine. And here I do have a few examples for the products which where we are doing a lot of research and development. So very modern products like powder products, which are used for the vegans and other people who are interested in the ingredients. Very interesting values of proteins and fatty acids as well. Plus, we do have the cannabinoids, the phytocannabinoids, and some vitamins in these products. We have a quite interesting range of different oils, which are nowadays used for the wellness. Everybody must know the CBD oil, which is on the market since a few years. And in addition to that, it is used for cosmetics and for animals as feed oils as well. We have founded a institute maybe 4 years ago in Slovenia, where we do the international research on these cannabinoids as well. And we start with the seed, and we do the multiplication of seeds since a few years now, and we are in between with a very good contact with other breeders, and we are looking quite deep into the plant as well. And since a few months only, some guys in Switzerland has done a very good job, as they are now has been identified the whole genome of the hemp plant as well. So it is very, very interesting to know all about the DNA of that plant. Here you see the seed, which is for food, feed, and for sowing as well. This is our development, just a little bit about the acreage, which has been increased since many, many years now. These are only the latest years. And now we are coming to a very interesting overview about the benefits if you look into human nutrition. And you find so many arguments on that page, and I'm totally convinced you will love them, because you are interested in very good foods for your nutrition. The main arguments are the very high ratio for unsaturated and fatty acids. We have the perfect ratio from 3 to 1 from omega-6 to omega-3. The protein content is interesting, as you find all essential amino acids in it, and the digestibility is very, very high. So that is very helpful, as the bioavailability helps to feed you with these products. Many, many good arguments, and at least on the bottom of the page you see we are doing it on organic farmlands, and we are doing it in a sustainable environment as well. So now here a kind of a small catalog of our products, from the seed, the leaves, the leaf powder, the oil, and moreover we do have flower products which are very famous now. People are interested in substituting nicotine or tobacco by smoking it, as you might have heard. And we have, of course, the extracts, which are concentrated cannabinoid ingredients used for these CBD or CBG oils. And we have a lot of feed products as well for chicken, cattle, and horses as well. This is a overview of our end consumer brand. So this is what you can find in the shops, where you can buy chocolate, tea, protein powder, or of course the very healthy oils. And another part is product development. We are looking into new extraction machineries. We are looking into biochar, especially made from hemp. The fiber and the straw content is very, very interesting, as building industry has a huge demand for good products which are sustainable and have a good impact on the CO2 circle. Here you see where I am traveling. Former days I was traveling pretty much more than the last 1.5 years. So now we are doing it more from our own lands here in the center of Europe. I'm coming to the end. I'm showing you my colleagues and my partners and my friends. A very, very tight network which we have in Germany and moreover in Europe as well. We are working with universities, we are working with media, and I'm ending with the idea telling you most important is our European Industrial Hemp Association. If you would have any further questions, if you would have any demands, international demands, and so on, we do have kind of a very good colleagues in Brussels now. Not only our managing director, but her colleagues as well. They are helping a lot with getting the connection to the politics in Brussels as well. So do not hesitate to contact the European Industrial Hemp Association. And I thank you for the time, and I'm looking forward to any question you are sending into the chat. This is it from me, and thank you.
Well, thank you, Raphael. Thanks so much for introducing us to this exciting crop of the bioeconomy. I've seen already some interesting questions are in the chat, which we are picking up later. So thanks again for being here today. I think it's a wonderful opportunity also for the discussion later. And with that, I would like to go to our fourth presentation. We have actually two colleagues here who will talk about another very interesting crop, and that is actually tobacco. And our two colleagues here are Inge Breuer. We apologize that Inge's name has been misspelled on the screen here, so it's not Inger, it's actually Inge. We couldn't change it so quickly, apologies for that. So Inge is chair of agrobiotechnology at the University of Rostock at the Faculty of Agricultural and Environmental Sciences there. She is certainly one of the most renowned expert in the field of agricultural biotechnology, certainly in Germany, but also internationally. But as an indication of her expertise and recognition in this field, just to mention one aspect, since 2013, she has been the chair of the Commission for Genetically Modified Food and Feed of the German Federal Institute of Risk Assessment. And she will share this presentation with her colleague Ursula Weisenfeld. So let me introduce Ursula as well, so that we can then both hear both parts of the presentations together. Ursula is professor of business administration, in particular innovation management at Leuphana, the University of Lüneburg, and there at the Institute of Management and Organization. Ursula engages in research and teaching on innovation-related topics, such as management of change and international technology management, which with a focus on sustainability. This is actually also what Leuphana University is perhaps most famous for, and she is also involved in executive education. So thanks so much both to Inge and Ursula for being here with us today. And again, I would like to encourage everyone in the audience to ask questions in the chat while our two experts are speaking. And with that, I would like to hand over the floor, or rather the screen, to you, Inge. I think Inge goes first, and then Ursula will join. Inge, please.
Yeah, thank you very much, Regina, for this kind introduction. And Eustos for the invitation to come to this meeting. That was really nice. I would like to talk about the project that I actually do together with Eustos and Oshi. And this is a project about sustainable co-production of biopolymers. So it's actually the idea David talked about, that we try to reduce the area of land that is used for production of, for instance, renewable resources. So with the idea to just produce an additional compound in a plant that's already in the field without any additional input, so no other fertilizer, and hopefully no loss of biomass or whatever. So our project is funded by the EU. It's an IRANET project, and we have 6 partners. Bioceres is the company in Argentina, which is actually now releasing the transgenic wheat, and they are doing the field trials. Then we have Eustos in Wageningen taking care of the money in the project. So he's actually responsible for economy. And then we have the Food and Bio-Based Research Institute in Wageningen with Jeroen Hogenholz, who is working on new products from cyanophysin and also supporting us in developing a new method or improved method to isolate cyanophysin from the plants. Then my institute, the University of Rostock, who is doing the transformation of plants. So we work with cyanophysin producing plants in many, many years. Then we have Sancam, a company in Italy and the Netherlands that is providing the variety, the tobacco variety we are working on, and is supporting the field trial. And then Leuphana University, Oshi's university, and she's responsible for socioeconomics, and she will talk about her subject later. So our aim is, as I said already, to use tobacco as a plant that produces an additional compound. And tobacco is actually already grown for the production of oil. Not many people know about, but it's actually the case that this oil is used for airplanes and other engines. So it is already produced, and we want to add our cyanophysin there. So, and then optimize the isolation and see the social impact. So it really combines plant and industrial biotechnology. What is cyanophysin? It's a word someone said to me, I'm not allowed to call it cyanophysin because it sounds so toxic. I'm sorry, that's the name, so I can't change it. And it's cyanophysin because it comes from cyanobacteria, who produce it as a storage substance, and they only use one gene. So that's non-ribosomal protein synthesis. It's only one gene that has to be transferred to other organisms to produce cyanophysin. And this cyanophysin synthase that's produced by this gene, it just adds arginine and aspartate dipeptides to a precursor so that you get a molecule that has a certain length. In plants, it's about 25 kilodaltons. In E. coli, it can be much longer. So that's the molecule just produced in the plant. And you see here the storage compounds in cyanobacteria where this cyanophysin is stored. What can we do with cyanophysin? We can hydrolyze, so we just separate the arginine from the polyaspartate backbone. And the arginine can be used as precursor for nylon, urea, diaminobutane, so quite a lot of different applications. But it can also be a feed supplement or functional food. And there are many, many studies who show the benefit of arginine as supplement in feed and food. And actually, there are already people feeding their fish with cyanophysin, so as an additive for sure, not only cyanophysin, because it's so healthy and supplies the arginine the fish need. The polyaspartate backbone can be used as substitute for polyacrylates that have many applications in diapers, in concrete, in very, very many other things as calcium binder, for leather industry, cosmetics, detergent, as a substitute for phosphate, and so on. Why tobacco? We tried many other plants, pea, potato, even also hemp, actually, because we wanted to improve the fiber quality, but hemp is not transformable. That's why it is GMO-free. But tobacco was the plant with the highest production and the lowest yield penalty. We go up to more than 10% of the leaf dry weight in cyanophysin. So that's really a huge amount of substance. There's no other example. You have such a lot of new compound in the plant. We were able to develop a method to produce tobacco silage, and CGP, cyanophysin, is stable in tobacco silage, so we can store the harvest after harvest. And we hope that this might be a new market for the tobacco farmers because the cigarette demand decline. And we hope that we have an additional value for those people who grow tobacco for oil production, so they have a better income. While the variety SL632, this is a variety with really large yield of biomass. It is resilient in diverse climates. So you see here all the areas where it's growing. There's a high seed yield, and the leaves are nicotine-free, so they can be used as feed directly. And this is how SL632 is used now. So the seeds are used for oil production, and the seed cake is used as feed. And the leaves are also used for fiber production and as feed. And we just want to add cyanophysin to the leaves. So no additional land, no other input required, just an additional compound, additional value. The project is divided into 3 working packages. The first deals with a tobacco variety that we had already in the lab and was the first in the field trial. Then we introduced the CGP production into SL632. And the third work package is the socioeconomics, and Uschi will talk about that later. So this is the result from the first field trial. What you see here is that we selected 6 events out of 32 we tested, and here you see the CGP amount per plant. So it already includes the biomass and potential losses of biomass. And you see we took 2 plants with low CGP content, 2 with middle CGP content, 2 with high CGP content, because we had no idea how they perform in the field. And this is their offspring in the greenhouse and in the field. And you see, because it's the offspring, there are many, many plants, and this is very high variety in the CGP production in the different offspring. The variation in the field is much higher than in the greenhouse. But you see that the yield in the field is much higher, and as high really as in the primary transformance. And this is not everything you can get, because this was a very short experiment. We went into the field quite late because it was difficult to deliver the seeds, and we had to harvest too early. So I think in the next years we will have much more cyanophysin per plant because the biomass is increasing. And here you see a bag with hemp silage, hemp silage with tobacco silage. So then we did this isolation of cyanophysin, and we were really able to upscale it, so to isolate cyanophysin with over 90% purity from huge amounts of silage and of normal dried leaf material. We could shorten the process, we could reduce the centrifugation, so we reduced the energy process. And we are currently working on the substitution of the acid extraction. That's still part of the isolation process to make it easier for an industrial isolation. And this is what we are doing in, or Jeroen Hugenholz is doing in Wageningen for new applications, who is either using the side chain removal, polyaspartic acid and arginine, and then looking for applications like chelating agents or hydrogels. And he's also using the whole cyanophysin, for instance, for responsive hydrogels, for multi-layer systems, but also for wrapping paper with antimicrobial effects because it's coated with cyanophysin. And Uschi will talk about that later. So then we have field trial 2 that is running in the moment. So SL632 is in the field now too. This is the repetition of the Badisch-Goidertheimer field trial. So this is the second generation. We have always 6 events and 4 repetitions. And we are really eager to see how the Cyanophysin production will be this year. And I hope we will harvest at the end of May. And these are the SL events we put into the field. Again, 2 was low production, middle production, high production. So the blue bar is always the Cyanophysin content. The orange bar is the biomass that you can see here. It's lower, here it's higher than the control. This one is again lower. But what you always see, the brown bar is the seed production, and that's always lower compared to the control that do not produce Cyanophysin. So in the moment, we are working on leaf-specific expression to reduce the effect on seed production and seed weight. And here you see the plants in the field. So actually, to summarize what we have done, I think we can say that we are able to produce high amounts of Cyanophysin in plants. 4 grams per plant in the field is really nice. And I hope we are able to increase this amount even further. We have low yield production, but we have an input influence on seed weight, so we are working on that. We have the isolation protocol, we have the application possibilities. So that's all quite nice, but has to be accepted by the public. And this is what Uschi will talk about, and I thank you very much for your attention.
Well, thank you very much, Inge. And without further ado, I would like to invite Uschi to continue. We may have to transition the slides here. While we are doing this, I would like to invite everybody of the audience to please ask questions in the chat. This is the opportunity. And we are still in the transitioning of the slides. I think it will take a few more seconds until we are actually there. Yeah, that looks very promising.
Okay, so thank you very much, Inge, for...
We can't still see your whole screen. Maybe you have to go in presentation mode, perhaps. That might help.
I thought I did that. Now?
Yes,
yeah.
Perfect.
Okay.
Please go ahead. Perfect, thank you.
Okay, thank you very much, Inge, for introducing the project, and Regina for introducing myself. In the abstract of this webinar, it says that the bioeconomy has potential for well-being and for sustainable production, and our project is actually addressing these different issues: sustainable production, but also the well-being of farmers and the providing opportunities, for example, for small farmers for their production. But on the other hand, the best technology, and we heard already that the economic and scientific evaluation of genetic modification is very positive, but the best technological approach doesn't work if it's not being adopted. And that is something that we are also addressing in this project, namely that we are looking at the adoption of more sustainable practices. And this relates to the acceptance, appreciation, and usage of innovation or a technology. And so what are the prospects of adoption by the local community, by farmers and by consumers? And we all know that for over the last 30 years, genetic modification as a technology, gene transfer, but also gene editing more recently, has been viewed very with suspicion in the public, especially in Europe. And the Eurobarometer, for example, repeatedly has shown that citizens don't like it very much. We see in various different journals, whether it's sociological or management journals with an emphasis on risk perception, or food and agriculture, again and again, that the perception of these products derived from genetic modification actually are not very favorable, have not a favorable reception. So our big question then with regard to this project was whether consumers would adopt these products based on genetic modification. And, to that end, we did a choice. So that was one part of our project, a choice experiment with 6,000 citizens from 4 European countries, Finland, Germany, Italy, and the Netherlands. And we split that sample in 2 applications. So half of the respondents were faced with food wrapping and the other half with a skin cream, where we incorporated the cyanophysin of our project as part of the material for these products. And so what is that? So we conducted a choice-based conjoined experiment. I here concentrate now on the food wrapping. And we had 4 different attributes. One was material with 5 levels. Then whether there was a bacterial coating, yes or no. A certificate for environmental benefits. There were 2 different certificates, and also the option of no certificate, and different price levels. So whether you have to pay for the wrapping, the food wrapping. These attribute levels were randomly varied through the across the hypothetical choice situations, and each respondent was presented with 12 choice sets, and each choice set had 4 alternatives plus the no choice option. So if respondents considered none of the 4 alternatives as acceptable, they could also click on the no choice button. Before we exposed the respondents to these choice situations, we explained the food wrapping. So we said, with regard to material, there were 5 different types of material, namely conventional, based on petroleum, so the plastic bags, this plastic wrapping that we usually find in supermarkets for vegetables, for bread, and so on. Increasingly, you see paper, recycled paper, which very often is only partially compostable because of the ink in the print. Then our GMO bioplastic packaging, which we explained was based on genetically modified plants as a byproduct. Then natural material, you might have already eaten chips in a cup that you can eat, or banana leaves that you can wrap around food, and so on. And then also the question of no packaging, that you take the bread directly into your basket or into the linen bag that you provided yourself. The experimental design thus looks like this. So material, these 5 options that I just explained, the antibacterial coating, yes or no, the certificate, 2 kinds or none, and the price varies from 1 to 50 cents as the price for the wrapping. Yeah, and these are the results. So we have here 4 countries, Germany, Finland, the Netherlands, and Italy, with a respective sample size. And we see, so the baseline comparison, so this is focusing on the material, because this is, of course, very interesting to us, not so much the other characteristics, but mainly the material. And the baseline is the conventional plastic. So that what we see in supermarkets, that we can wrap our fruit, vegetables, bread, and so on. So the baseline, the conventional plastic. And what we see here in these 4 graphs is that the orange column represents our GMO cyanophysin-based plastic. And we see that compared to the conventional plastic, for all 4 countries, that is positive. Maybe the next remarkable aspect of this picture here is that the unwrapped option enjoys particular popularity in Germany. So here the unwrapped option has the highest utility. On the other hand, in Finland and the Netherlands, we see that this is not considered as appropriate. It's even less useful than the conventional plastic wrapping. But in general, these results show that, contrary to what we have learned in the last decades about perceptions and preferences for genetic modification in agriculture, green genetic technology, in this study, it shows that in all countries, the part worth, so the utility estimated from the experiments based on these samples, is positive. The utility is positive compared to the conventional wrapping. Maybe second, very interesting result is that no wrapping is the most popular option in Germany. We see in Germany many so-called unverpackt Läden, so shops where all the produce is offered without wrapping, and where you either buy your wrapping, reusable wrapping in the shop, or you bring your boxes yourself. And another interesting example is that for all other countries, it's not only compared to conventional plastic, but that the GMO plastic wrapping has the highest utility, is considered more acceptable than paper or the conventional or the natural banana leaves or whatever. So we think that this is a very encouraging result with regard to the adoption and possibly the diffusion of these products in the social systems. So thank you very much.
Well, thank you. Thanks a lot, Ursula. I think that was really a fascinating experiment, and we already also have some questions on that. So virtually, I think we should all clap for the presentations, because this ends now our set of presentations, and we can now actually go into the question and answer sessions. So I've been monitoring the questions that have been coming in and try to group them a little bit, but please feel free, because we do have actually half an hour. We have full, thank you all to speakers for keeping the time. So we do have a full half an hour for our discussion here, and some questions have actually also been answered already in the chat. There were some questions on, for example, Lorenzetti had asked whether regenerative agriculture is part of the bioeconomy. I think that is a very interesting question. We have a lot of different concepts that refer to sustainable agriculture. Yeah, there's organic farming, there's agroecology, and so on. And one concept that also big companies, for example, use is this regenerative agriculture. Yeah, and maybe Eustos, you can just quickly tell the answer yourself, that even though it was in the chat, just quickly.
So that was the Eustos from the United States that was answering.
Oh, the
so
other
basically
Eustos, sorry.
David. So now
Okay.
Eustos from Europe answering. Yes, regenerative agriculture or organic agriculture, other different forms of agriculture, of course, are part of the bioeconomy. So there's no singling out of specific systems of production, neither at the production level or at the further processing levels. This is all considered. And with regenerative agriculture, I had to Google this to know exactly what is meant by that, but this focuses on using or improving the soil capabilities and maintaining soils and increasing soil productivity. And in particular, this will definitely become an important part of the bioeconomy in the longer run, when we also, and now I refer to the question that has been raised with carbon storage with respect to the hemp production, increase in importance. And there might be then the possibility that carbon credits, with the new changes in the EU and in Germany and other country regulation on climate change, that compensation or payments for carbon credits may become a policy tool to be implemented. And then in particular, those kind of production technologies like the hemp may benefit from such kind of policy.
All right. Thanks a lot for answering that question, Eustos. Another question, which also, if we start with general, what's our understanding of the bioeconomy? There was actually another question related to our understanding of the bioeconomy, and that was from Ludmila, who was asking whether there is room for traditional knowledge such as polyculture, and what role should it play in the bioeconomy? And now I'm not sure whether which of the two Eustos, whether it was David. Did you comment on this question?
To me, I think the traditional knowledge is the essential element of the bioeconomy. What really happens in biology is that we have two elements of biology. We have molecular biology and we have organismal biology. And traditional knowledge is part of organismal biology. And I think the biggest challenge today of molecular biology and the bioeconomy is to incorporate all the knowledge systems that we have today to produce an integrated system that really incorporate all what we learned through the generation. The biggest challenge that we have is as economists to compensate people that preserve traditional knowledge and have traditional knowledge, so it can be incorporated with tools of bioeconomy. But without modern biotechnology, a lot of time you cannot utilize traditional knowledge because the bioeconomy allow you to incorporate a lot of new plants and other practices into a modern system. So so everything is integrated. So and the same thing is regenerative agriculture. What we really want to do is to develop a holistic system that incorporate all the tools that we have into one, and all these tools are working with harmony. So there is a word that is very popular in America, inclusion. And I really see the bioeconomy as an inclusive process, an inclusive system that incorporates all what we know from physics, all the traditional knowledge, regenerative agriculture, and has to be married with organic agriculture. So in a way that basically we have systems that reduce greenhouse gases, increase yield, enhance biodiversity, and also increase the income of farmers all over the world.
Well, thank you so much, David. I think that really lays out the understanding of the bioeconomy. I think we could also stop the screen sharing, then probably the audience can see the speakers better here if our administrative assistants could help with that. Yeah, maybe one more question on the overall understanding of the bioeconomy before we go to more specific questions. And this was Lyudmila Chatalova asked Eustos, in your opinion, how will the currently discussed draft amendment to the Climate Protection Act affect NPV costs and benefits from the bioeconomy? Perhaps you can also say a few words what this amendment actually refers to when answering this question, Eustos.
Yes, so the what we have now on the policy agenda is that the carbon dioxide emission objectives or goals that have been set have been even further increased. So, for example, that Germany wants to reach its goals earlier than it has been agreed upon at a European level, and with the previous regulation, and also at a European level, the standards or the ambitions have increased. Now, what would this imply then for the bioeconomy? Well, in many cases, it will depend on how the policies will in the end then being implemented at national level. In general, what we can expect is that this will provide better opportunities for the bioeconomy, in the sense that many of the examples that we are seeing result in reduced greenhouse gas emissions in comparison to the second best alternative. Then what are the plans now is that if they introduce carbon taxes, that these taxes will be used to stimulate investments in technologies that reduce carbon dioxide emissions. So if you get these direct investments, then of course the net present value of these kind of investments will increase. Now, then there is another issue that is, even if we have this 2 or 2.5 degree goal being achieved, what the studies that do tell us is that this still will have an effect on agriculture production, right? So even with 2 degrees increase. And there, I think that that is where the bioeconomy will really matter a lot. And what David has pointed out, and many others, is that we need new technologies, new innovations that being adapted to be able to adapt to the climate change. And there the bioeconomy possibilities will be very instrumental to achieve this. We have seen the example with the tobacco, right, where you have an alternative production system that may generate additional income for tobacco growers. Now we have other examples. We have seen the hemp example, where hemp, which is increasing the carbon storage in the soil, can be an alternative to the current production system and generate benefits. And those kind of technologies will further benefit. So they will observe an increase in the net present value relative to the other technologies. So from that perspective, climate change is, the bad impacts of climate change are good for the bioeconomy.
Okay, I think that was a good summary of this point. We certainly may raise some further questions, but before we go into further questions in that topic, I would like to pick up the questions that were actually directed to David. You highlighted the role of GMOs, and we have a number of questions. I actually have grouped them into 3 types of questions. There are some questions that relate to the acceptance of the bioeconomy, specifically in Europe. So, for example, Victoria Storm says, the acceptance of GMO technology is very low in Europe. What do you think could trigger the shift in the acceptance? We have another question from Mure Akbalan Lahore. He says, thanks, David. The economic and environmental benefits of GMO in agricultural production are always stressed, but still the low adoption persists. Over the years, there's even a decline. Taking calculated risks as suggested may not fly with a population with such morbid health concerns. Speaking of the risk attitude in Europe, I guess. What is your suggestion on the game changer to attitude? Maybe we answer these questions first before we go into some other aspects of this GMO. So low acceptance in Europe. David, what's your take on that?
My feeling is this, that I studied it for 30 years. Generally speaking, almost all over the world, about 50 or 60% of the population don't care about anything if the price is right and if the food is doing it. And the rest of the population is changing their mind. The main issue in Europe, and the same is in the US and any other country, is the policies that don't allow people, a GMO product to enter to the store. So, for example, the key story in the history of GMO was that when McDonald's wanted to introduce a GMO potato, activists put signs and told the store, okay, we will boycott you if you introduce it. And McDonald's basically withdrew. So to some extent, today there are regulations that don't allow farmers to produce a GMO. The moment that these regulations are removed, I think that farmer will produce it. It will be in the shelf. In the beginning, few people will use it. Then most of people will use it. It's like vaccination. Many people said that they wouldn't be vaccinated, but they will be vaccinated. That's number one. Number two, the name is changing. You don't need to call it GMO. And GMO will be replaced by CRISPR. The challenge for me, I don't worry, of course I worry about GMO, but I worry more that this new technology will be accepted. The key element is that Europe cannot divorce itself from modern biology. The continent of Pasteur and Koch cannot be the continent that is now going to the Middle Ages. So to some extent, people that are fighting, it's politics. If Green parties realize that they can use it as a mechanism to demonize technology and develop some unscientific methodology, you know that you cannot go with this approach and also fight climate change and do other things, and you cannot be a leading country. Now, I have several interesting examples. Bangladesh, where people are quite prejudiced, have a BT eggplant. In the beginning, people said that it wouldn't be accepted. Today, the price of BT eggplant is 15% higher than regular eggplant because they are better. So to me, the issue is put it on the shelf. The moment that it will be on the shelf and it's enough that 2 or 3 chains will do it, it will spread everywhere. So to some extent, the issue is not that every person in Europe is anti-GMO. The issue is that there is a political price for introducing a GMO, and there is a political driven stigma. But the moment that that someone recognizes that it's legal and there is an opportunity, I believe that things will take care of themselves. We eat tomatoes afterwards. It was about 50 years boycott of tomatoes. So, I really don't worry about it. I think it's more politics than anything else.
Thank you, David. Ursula, I think urgently wants to say something on that topic too. Please, Urshi, go ahead.
Yes, thank you. I want to endorse what David said, and I wanted to complement some aspects. I mentioned the many studies with regard to consumers, where consumers didn't adopt, where when you ask people whether they would like GMO-based food, they say no. So one aspect for me is a methodological point. If you ask people whether they like GMO, they are more likely to say no, quite apart from the fact that many people don't know what's involved with GMO technology. So what we did was a choice-based analysis where you have trade-offs, and you have trade-offs. We signaled to the respondents that the alternative would be fossil-based fuel wrapping. And at the moment, many people in Europe, and that again is from a Eurobarometer from 2020, are very concerned about plastic pollution. So this is a different concern that people have. And suddenly GMO as a concern might actually, when you look at the trade-off, might actually lose its image. And so I think it's first a methods problem, that you ask for opinions rather than trade-offs. And secondly, that by now a lot of problems that we see even in the rich Western world with climate change makes people think again. And that might also be a driver for the acceptance of technological alternatives and looking a bit more closely to what's actually behind it, rather than just saying blankly, I don't like GMO. So that is also what I wanted to add, what David said.
Yeah, thank you, Ursula. Thanks a lot. I mean, it's not so encouraging to hear that the German Ministry of Environment just a few days ago issued a position paper that clearly says we we insist on our position. But there was another. Rosalie, I want to comment on this as well.
Yeah, just on that, because that is another example. I just read an article from 2016 by colleagues who talked about institutional stakeholders. And it's very often that some stakeholders who have very much power influence these governmental agencies. And that is clearly the case here as well in that recent publication, this recent proposition.
Okay, David, directly to that, maybe just short answer because we have a long list of other questions, but please, David, go ahead.
This is a very short answer. There is a big difference between environmental scientists and environmentalists. A lot of times, people that call themselves environmentalists, to me, it's more than a religion than a scientific-based activity. As an environmental scientist, sometimes I support what environmental groups are saying, and sometimes I don't. And I think the same is true with other scientists. So to some extent, a lot of time, environmental ministry is captured by people that are more so led true believers rather than people that do science. And this is the challenge that we have with political system. All over the, not all over the world, but in many countries in the world, environmental ministries take an anti-GMO perspective, even though GMO is supported by all the national academies of science that I know.
Yes, David, I think that is a very contingent, very good observation. It's actually also my own observation of this German Ministry of Environment seems to be influenced by such interest groups. But there was another question, a very specific one in a similar direction, actually to Inge. Inge, are you able to do the field trials that you described, this SL632 in Europe? And do you anticipate being able to grow these crops commercially in Europe? Inge, what's your take?
We did quite a lot of field trials in Germany, actually, many years ago, but we're not able to do it anymore. So we will not get the money from the government. We will not to do the field trials, and we will not get the permission to do the field trials from the local government. So actually, it would have been impossible, I think, to do the field trial in Germany. And on the other hand, it's better to grow tobacco in Argentina than in Germany, actually. I think so. That's,
okay.
That's the positive thing there. And our idea for Europe with this project is that the Cyanophysin will go to Europe to be then marketed there, used there for products and so on. So I think actually from a world perspective, it's much better to grow plants like that in countries that really profit from that. And but for sure, I would love to see more GMO plants in Germany in the ground, but this will take time. Maybe I just add that maybe you all know that there has been a paper from the Young Greens in Germany that's on the Green Party side, where they really say that GMOs should be deregulated and that we should have a better look on GMOs, and they even apologize for what has been done to the scientists working on GMOs. So I think there's hope. So we should not be too depressed about it. Things will change. I mean, the old people like me will die out, and then the young people will be there and use it.
Yeah, thank you. I think for this feedback, it's yeah, just maybe for European audience. So in Germany, in view of the national elections coming up in fall, the Green Party has really changed their position a little bit as compared to previous to their previous platform, by not saying we have a categorical no, but by saying just like putting it the other way around. So this GM-free production should still be labeled and possible and protected. It's different with the Social Democrat Party, who now still says they want a clear no. But this aside, I think we had two interesting questions that relate to possible drivers of change. Eustos, you want to intervene, please?
Yes, just to add to what Inge and Ursula has said, this tobacco project is very interesting from a political point of view. You have a technology being developed in the European Union. We transfer this to Argentina to cultivate this there. And now the big question, and that is what I'm very excited about, is will Europe accept the imports of these products into the European market? It would fall under the GMO regulation. That is what we have so far understood how the regulations will look like. But it's a gray area. And that is for us is a very interesting thing, how to look at it when these products are later being marketed, how Europe will handle these products when we talk about imports. So that is quite fascinating from a research perspective as well.
Okay, Inge, quick answer?
Yeah, quick answer. We have a lot of products that are deregulated for import. So nearly everything that's made in
Yes.
the world is deregulated for import in Germany. And you know that all our cotton, our money, our jeans, they're all made from BT cotton. And no one realizes that because this is non-food feed. And
yes.
This doesn't have to be labeled. And this will be the same for Cyanophysin products. So I'm absolutely optimistic that could easily get the permission to import it and to sell it because it's without any labeling. And the EU tends to.
Thank you for this.
I think I have somewhat of a different view, but we will see how this will emerge, right? So that makes it exciting. But Regina, please.
Yeah, in the chat, Inge, someone was asking for a link to this paper by the Young Greens. Maybe you can put this link in the chat. That would be a request from our audience here. And I have two questions here that relate to what could be perhaps drivers of change in attitudes regarding that. And Max Kardung was asking, do you think there will be a spillover effect from the success of mRNA vaccines for the acceptance of GMO crops? And then Carl Prey had a related question because he was asking where the regulatory delays for genetically modified COVID-19 vaccines from AstraZeneca, Johnson & Johnson, and the Russian ones. I'm not so sure who can actually answer these questions, but everybody who feels to in the audience like to comment on that. Do we believe that?
Yeah, let me first answer to the vaccines. So there has been a lot of debate within the media, etc., about how Europe was handling the case. Now, when we look at the approval process, so they have used what we call a rapid approval process, and that did work relatively well. So some countries have been UK and United States have for some of the vaccines a little bit earlier than the European Union. European Union has been earlier than on AstraZeneca, which has no approval in the US yet. And so there, depending on the specific cases, there are differences, but that is normal. But overall, there's not really a strong difference. The interesting thing that will be is what Max Kardung has asked. Will this have an effect on the other products? And there I'm personally, based on what we have observed in the past, I'm very skeptical. Uschi was mentioning the Eurobarometer surveys. We see a positive response towards pharma and a negative response towards food and agriculture. And I don't expect that this will change even with the COVID-19 pandemic. There, I'm very skeptical.
David, maybe you have a different opinion on the matter.
Yeah. See, I think that what really will happen is once all the COVID thing disappears, there will be reassessment, and it is up to us and the public and the scientists to have a debate, because at the end, I think what happened in the vaccine in Europe compared, let's say, to Israel or the US or England is quite a contradiction that people will be very unhappy with. And to some extent, I think, especially the failure of France with its incredible medical industry to produce a decent vaccine will raise question why. And that will be a debate. And one of the debates is that sometimes we take precaution too seriously, and we really have to think about it. So to me, as scientists, we really have to provide people some food for thought. To some extent, when you have an emergency like climate change or COVID, you have to respond very quickly, and you have to use the best tool. Mao Zedong or someone in China said it doesn't matter if it's a black or white cat as long as it catches mice. And I think that to some extent that will be quite important when it comes to the issue of modern biotechnology. So I think that there will be some lessons, but it's up to us to educate them.
Well, thank you so much, David, for that perspective. Yeah, I think it would be an interesting question also what kind of framing works and doesn't work. So Lorenza said, for example, as a comment, probably framing GMO products as carbon farming may also give it a new perspective apart from these spillovers. I would like to go ahead since the time is kind of passing. We had actually two more questions that referred more to the application of GMOs in developing countries. So Lorenza Lorenzetti said, Burkina Faso, one of major African cotton producers, since we were just talking about BT cotton, had a bad experience with GM cotton. So for those who do not know the details, they actually introduced it. But since the cotton quality was lower than they used to have in this market, they actually stopped it. So what do we make out of this? And then Bujevin Brandt says, would you expect the prices of seed in developing countries to rise? That question was actually already answered, but still maybe we could say a few more words on this GMOs in developing countries. Who would like to speak on that? Maybe just briefly. Eustos,
just
yes?
briefly on this BT cotton case in Burkina Faso. I think there's a lot of a lot has been said about this, but rigorous analysis so far shows that it seems to have been a case that is related to the quality of the seeds. Now, if you have this BT cotton and you would love to use this for the second and third generation to maintain purity, you have to have a strong seed control system in place. And what studies have shown is that this basically has not been maintained, so that the BT content of the so-called BT seeds in the second, third, and fourth planting was substantially lower than from the original seed. So it went down to 53%, while there was also then an admixture with a non-BT cotton, and some of the non-BT cotton samples that they have analyzed had BT cotton content of 64%, even higher than the so-called BT cotton. So there was a problem in the seed system. And that, of course, then results in not the expected implications for the protective impacts expected from cultivation of BT cotton. And for me, this seems to be the more reasonable explanation than some other explanation that has been forwarded. And we have seen similar effects in China, where we did a study that was in the mid-2000s on the Chinese cotton seed market, where we observed something similar, faked seeds. You write BT cotton on it, sell it, but it was not BT cotton, and the same. And there's a nice paper by Ron Herring on steel seed for India. There's the same did also happen. So basically what they do is they exploit the farmers. The farmers expect there will be great seeds. They've seen the benefits from it, and others free ride on this by faking the seeds. And so Burkina Faso is there no exception then to what we have observed in other regions as well.
Thanks for this clarification. I think we could discuss this further, but in view of the time, since we have only 4 minutes before I would hand over to Carl for this final remarks, we also had some questions to Raphael. I don't see him on the screen here. I hope, Raphael, you're still with us. So first, David actually had said he's speaking from a marijuana and hemp farm from his nephew in Oklahoma, and he really liked your talk, and he believes you would fit there perfectly. So I hope you have a chance to visit David's nephew's farm. And then Lorenza had a very specific question: is actually, do you get carbon credits for your carbon farming? And in case you do, is that from the EU or from others? And then a second, maybe I bundle these questions for you. A second question was, have you actually calculated the CO2 creation that occurs when making biochar? And then that was from Lorenza. And then Johnny Ogunji asked, regarding the use of hemp, have you done any research on fish nutrition, or do you considering that? Raphael, the 3 questions for you.
Thank you for the questions, and please apologize switching off the camera, because I do have a quite bad line here, so I was not able to follow any commands that I have not really heard here. And I hope you hear me well now. And
we do, yeah.
That's fine. Just in general, I must say I do not exactly agree with the many aspects of the GM technology in general, as I'm an organic farming expert, and I'm doing it since more than 25 years now, and I'm very happy with this system. And I do think when we look into the results, just in general in agriculture on our lands worldwide, these results are not very good. What we see is we have depleted lands all over the world. The humus ratio is going down and down, and what I see is there is a need of a huge change in agriculture in general, and there are systems available where you can change a lot, including all these questions about climate change and CO2 sequestration as well. By that chance. To answer the questions, we do not get any money from these carbon credits right now, so we are working on that. I guess it is just not the time now. We are not exactly at the point, but I'm looking into the future, seeing there will be a special grant coming from these carbon credits for the farmers. So I'm speaking here for the farmers, and so we are interested in getting some refunds for what we are doing here. And the second question to the biochar is more or less the same. We do not have exact numbers right now. So this is investigation and research, because the evaluation of the metric tons that are sequestered in the soil or in the products is not clear yet. So this is really research work, especially for hemp. We know it for some other plants, yes, but hemp is very special and very different. So we must look into it, and we will do that now. We are right now doing it. And at a certain point, I guess we will have the numbers to really show what can hemp do. We are talking in metric tons between 10 and 30 tons per hectare, maybe. And we are talking about money-wise, about 10, 50 or 100 euro per ton. So this is all not clear right now. I'm expecting this discussion not only in Germany, but in Brussels as well. And I guess for the next period of the common agriculture policy and programs in Europe, we will have some solutions there. About fish, of course, hemp can do a lot for fish feeding as well. There is a traditional seed variety in Turkey, which is called, yes, it has a special name because it has a very big size, and so you can use it for fishing as well. But you can use pelletized hemp seed products as well to feed the fish, and I'm open for any discussion and any questions about that.
Well, thanks so much, Raphael. I think now it's unfortunately time to come to the closing remarks already. I would like to ask our panelists to have a quick look in this chat function. There were some other questions, like to Ursula, whether you did actually calculate the CO2 footprint of the GMO wrapping. Maybe I would like to ask you, the presenters, to answer those questions in the chat. Also, we have the links now in the chat, so please everybody also consult the chat before closing. But at this point, I would like to invite Carl Prey. Let me also briefly introduce Carl before he gives his closing remarks. Carl is a distinguished professor in the Agricultural Food and Resource Economics Department of Rutgers, which is the State University of New Jersey. He has been the president of ICABR, of the International Consortium on Applied Bioeconomy Research. The focus of his own research is on agricultural science and technology policy in Asia, Africa, and Latin America. He's certainly one of the world's most known experts in this field. Also, his expertise, for example, on agricultural research investment in the private sector, I would like to highlight. But I think I could say much more, but for reasons of time, Carl, we are very happy that you are here today with us and that you give your perspective on this discussion in your closing remarks. So the screen is yours, Carl.
Thanks, Regina. I presume you guys can all hear me now.
Yes.
Thanks, Eustos and Biomonitor group for organizing this session. And I've been silent so far, but I have put in a number of little questions in the chat box. So I'm looking forward to a few more answers before the end of this seminar. And it clearly has been well received. Because of the chat shows that there's generated a lot of interest. I guess I just wanted to talk about very briefly about three sort of issues that have come up, and then put in a little plug for the ICABR conference that's going to be at the end of June and beginning of July, which is going to deal with many of these same issues. So the first point that I'd make is the importance of new science and technology, and it's clear that it's being used extensively in all of these case studies and also in the world at large. And the thing that is sort of striking is, of course, we're in this COVID vaccine world now, which has again emphasized the importance of innovation and the importance of the ability to use all of the tools that are available to us, such as the mRNA vaccine, which had never been used commercially before or on people before. These new adenovirus vaccines that I referred to, the AstraZeneca, the Johnson & Johnson, and the Sputnik vaccines based on a genetically engineered molecule, and the importance of that has been highly emphasized by the epidemic and by their success. And I appreciate David's remarks that I think that it does make an opportunity for a number of countries to look at their own both precautionary view of the world and also the way they support or don't support technology that is something that's very intriguing. But beyond that, the importance of advances in biology and in some cases officially biotechnology is also important. And I mean, we saw that even for the hemp story, that the scientists there may not use GMOs, but they greatly appreciate the genomics research and the advances in genomics that have been made. And there was a reference to the complete sequencing of the hemp genome, which is clearly going to be very important to them. So that there are many advances that are being made that some of them, I mean, almost all of them require GMOs in one sense or another, but they may not produce what are now considered GMOs. And so there's a lot of interesting work going on that I think is going to see the light of day, no matter what happens with European GMO regulations. I mean, I take some hope, and I know people, many of the people in this group have heard this about a million times from me, but I finally do see China, given their interest in reducing their greenhouse gas input, production, and reducing their use of chemicals, and then also trying to become competitive globally in technology with their purchase of Syngenta and with their changes that are going on internally. You see that GM corn, BT, and Roundup Ready corn are expanding rapidly in northern China, and it looks like it's going to be officially approved as legal in a few more months at least. So there are big changes not only globally in the ideas in Europe, but also in the rest of the world. So the second point, technology. Second point that was really, I thought, one of the interesting things that came out of this discussion is is the politics of technology in Europe. And I was it's really interested, particularly to hear about what's happening with the Green Party and the Young Greens and beyond. It makes one think that maybe there are ways to leverage both these changes in opinion in Europe, along with the successes of these vaccines to actually open things up a bit to these advances in technology. And that I think further discussions of these are going to be really interesting. And that then leads me in my last minute to my plug for the ICABR conference that's going to take place, as I mentioned, at the end of last day of June and first few days of July. It's going to be, let's see, the official title of it, which I always forget, is the role of the bioeconomy in generating resilience and sustainable development. And if you want to learn more about that, you go to icabr.net and check things out. We have a great lineup of speakers. Ramanan Lakshminarayan, who is an expert on an economist and an expert on viruses of various sorts, is going to be our leadoff speaker. Joachim von Braun is going to talk about bioeconomy and food systems, the UN Food System Summit. Chai-Xia Gao, one of the leaders, biologists that's a leader in the development of improved CRISPR technology, is going to speak to us about her work and what's happening in China with biotechnology. And Chris Barrett, who is one of the leading economists in the field of resilience, is going to be speaking to us about that. So this is going to be primarily online this year, unfortunately, but that means it's much more readily available to people and a lot cheaper, I suppose, than the past conferences have been. If you feel energetic enough, or I don't know exactly how to describe it, but there is going to be a small group, or maybe a big group, in Ravello, in our home on the Amalfi Coast, that will be meeting. And so you're welcome to join some of us there. And we hope that you will join the conference. And again, we thank everybody for your participation, and the organizers for organizing this. And it was a extremely interesting session today. And I hope everybody else got some new ideas out of it also, like I did. Okay, thank you. I think that's it.
Thank you, Carl. Thanks.
Yeah, welcome.
Thank you. This ends our session. It was really wonderful, and stay in touch. Thank you all for participating.
Bye.
Carl, do we meet later today?
Sounds like it.
Yes.
I guess so, yeah.
Raphael, thanks a lot. And Ushi and Inge, thanks a lot.